Hi friends and welcome to Geeks for Geeks. In this tutorial, we will discuss how to check if a given array can represent pre-order traversal of a binary search tree. So here's the problem. Given an array of numbers, return true if given array can represent pre-order traversal of a BST, else return false. Let's discuss a solution to this problem. First, we create an empty stack and initialize the root as int_min. Then, we iterate through the entire array and do the following for all the elements. If the ith element is smaller than the current root, we return false. Else, we keep removing elements from the stack while pre of I, that is ith element of the array, is greater than the stack top, and make the last removed item as the new root. At last, we push ith element of the array into the stack. Let's implement our algorithm on this example. First, we initialize the root as int_min and create a stack. Now, we will iterate through the array. The 0th element of the array is 2. So we push it into the stack since it is obviously greater than int_min. Next element of the array is 4 and it is greater than top of the stack, which is 2. So we pop 2 and make it the new root. At last we push 4 into the stack. Next element of the array is 3, which is greater than the root, so we can continue. It is smaller than the top of stack, so we do not need to pop anything from the stack. So at last we push 3 into the stack. We have iterated through the entire stack, so we return true and our BST is this. Let's look at another example. First, we initialize the root as int_min and create a stack. Now we will iterate through the array. First, we push the 0th element into the stack, that is 2. At I equal to 1, we have 4, which is greater than the current top. So we pop 2 from the stack and now 2 is the new root. And then we push 4 into the stack. At I equal to 2, we have 1, which is smaller than the current root. So we return false. Therefore, this array cannot represent pre-order traversal of a BST. Let's discuss the implementation of this problem in C++. First, we create a stack and initialize root as int_min. Then we iterate through the array. If the ith element of array is smaller than the root, we return false. If ith element is greater than the top of stack, we continue to pop elements from the stack and make the root as the last removed element. At last, we push the ith element into the stack. If we iterate through the entire array without falling into this statement, then we return true. The time complexity of this solution is O of n, since we iterate through the array only once. This brings us to the end of this tutorial. Thanks for watching. Please leave us your likes and comments in the comment section.